Welcome children to another video session in maths. The previous day we had started chapter circles and we had learned a few interesting things about chords. If you remember, we had learned if chords are equal, they make equal angles at the center. Similarly, it's converse. If angles are at the center are equal, chords are equal. We had also seen that a perpendicular from the center to a chord bisects the chord. It's converse. We had also seen a theorem. Again, another important property of chords. First, let us see here. Suppose you have a circle, center O. You have two chords, AB and say here CD. Now, if AB is equal to CD, that is if chords are equal, they are equidistant from the center. That is, they are at equal distances. Equal distance we always mean the perpendicular distance. So, this is the perpendicular. Suppose this point is M. Perpendicular distance, this point is N. Then OM equal to ON. Okay, that is if two chords are equal in a circle. If chords are equal, then they are equidistant from the center. That is, if AB is equal to CD, then OM equal to ON. Again, same way the converse, if chords are equidistant from the center, then they are equal. That is, if converse will be if OM is equal to ON, then AB will be equal to CD. Okay children, another important property of chord. Now today we will see another theorem. Theorem 10.8 of your book. We had seen another theorem the previous day and we will be doing this one today. From this chapter you will be having the proofs of only these two theorems. What is said in this theorem? A circle, center O, PQ is an arc of the circle. This PQ makes an angle at the center. In this case, PQ makes angle POQ, this angle at the center. Same arc PQ makes angle PAQ on the remaining part of the circle. The theorem says if it so happens, then this angle at the center will be twice the angle at any point on the remaining part of the circle. That is, for example, if this angle, suppose this angle is 30, then the angle at the center will be 60. Clear children? An arc makes an angle at the center and the same arc makes another angle at any point on the circle, then angle at the center will be twice the angle at any other point on the remaining part of the circle. So this is we have to prove. So since it's a theorem, we first write given. So what is given to you children? An arc PQ of a circle with center O. Angle, the arc PQ makes angle POQ at the center and angle PAQ on the remaining part of the circle. What you have to prove? We have to prove angle POQ is twice angle PAQ. We have to prove this. Now, three cases can arise. What are they? Either this arc PQ is minor. You can see from the first figure, arc PQ is minor arc. Arc PQ can be the diameter, that is semicircle, or this one. Here arc PQ is the major arc. So PQ can be minor, it can be a semicircle, it can be the major arc. Now the proof for all the three cases remains same. let's see how do we prove it. For it, there's a small construction. What do? We join AO and produce it to a point B. Construction, join AO and produce it to B. Now see here, proof. Now consider this triangle OAQ. In this triangle, this one, angle BOQ is an exterior angle of the triangle. Isn't it, children? You know what is an exterior angle? Okay, so this angle BOQ is an exterior angle of the triangle, and you know exterior angle of a triangle is equal to the sum of two opposite interior angles. This is known to you. Okay, so we write here angle BOQ will be equal to angle OAQ plus angle OQA. And you need to write the reason. What is the reason? Exterior angle theorem. Okay. Now again see this triangle OAQ. In this triangle, OA is equal to OQ. Are they equal? Yes. Why? Because again they are the radii of the same circle. Okay, so OA is the radius, OQ is also the radius of the circle, therefore OA is equal to OQ. Now again you know this, children, in a triangle, if this side is equal to this side, angles opposite to them are also equal. Angle opposite to this is this one. So these two angles are equal. So in this triangle, since OA is equal to OQ, we can write this angle equal to this angle. Isn't it, children? Okay, so we write also angle OAQ is equal to angle OQA. You know the reason why? Angles opposite to equal sides are equal. Now children, you need to write the reason. Angles opposite to equal sides are equal. Okay, so therefore what can we write? Therefore angle BOQ, this one, OAQ plus, instead of OQA we can again write OAQ, that is twice angle OAQ. Okay, children. Now similarly, let's come to the other side. Similarly, angle BOP. So this angle will be very similar to this, twice OAP. Now you can put this equation 1, you can put this equation 2. Now adding 1 and 2. So adding 1 and 2, what do you have? Angle BOQ plus angle BOP, this one. So if you add the two, what do you get? This full angle, and this full angle is angle POQ, equal to twice, you can take out common, OAQ. This one is OAQ and OAP. OAP is this angle. So this total is PAQ. Twice angle PAQ, and this is what we had to prove, that is angle POQ is twice the angle subtended at any point on the remaining part of the circle. So the proof remains the same for all the three figures, only for the last figure, instead of angle POQ, you will write reflex angle POQ. You know what is reflex angle? So so this angle is reflex angle POQ. So reflex angle POQ is equal to twice PAQ. Understood, children? Okay, now let's see another property. Okay, children, next, suppose we have a circle, this arc PQ, center of the circle. Now, this arc PQ makes this angle here, suppose this is A. Same arc PQ makes this angle. Same arc PQ can make another angle. Okay, so all these angles will be equal. We say angles in the same segment are equal. In this case, angle angle PAQ will be equal to angle PBQ equal to angle PCQ. We say angles in the same segment are equal. Okay, children, understood this much? Okay, so let it be up to this much for today. Thank you, children.